Previous class we have discussed on we have done the revision on module 2. In today's class we are going to cover module 3. In module 3 we will be studying regarding the composting, the different anaerobic and aerobic and anaerobic composting, then the description of it, then microbiology, then design consideration, mechanical composting, then vermicomposting we will be studying, then sanitary landfilling, advantages and disadvantages of sanitary landfilling, site selection, methods, then the gas leachate movement, then gas control. That this is what we are going to see in module 3 revision of module 3 of solid waste management. What is composting? Composting is nothing but it is a biological decomposition of organic constituents of waste under the controlled condition state sufficiently stable for nuisance free storage and utilization. It is a basically it is a mixing of the biodegradable elements with the soil in order to increase the NPK value of the soil, and hence it is going to increase the fertility of the soil. Instead of throwing the waste into the open land, we throw the biodegradable waste material under the controlled condition, we can improve the fertility of the soil by increasing its NPK value. So we are going to have the two types of objectives. What are the objectives of composting? To transfer the biodegradable organic materials such as your CO2, SO4 and nitrate we are going to get generated by having the composting, then to destroy the pathogen, insects, weeds, whatever it is there in the solid waste or in the soil. Then the fourth one is to produce a product that can be used to support the soil amendment, then composting yield that contains the manganese, your copper. Okay, then next is the uses of composter. The compost produced from your municipal solid waste contains around 1% of NPK value. During composting, the plant nutrients are converted into such forms that it is going to be covered for a longer period of time. Then it is going to have the manganese. Okay, it is known to contain the trace elements like manganese, copper, barium, which is essential for the plant growth. It is having a good soil conditioner, then it improves the ion exchange and water retention capacity of soil, then it increases the buffering capacity of the soil, then organic matter of the soil in a trapezoidal climatic condition is going to be get depleted by the microbial activities. Now the composting can be is having the two types under it, the aerobic composting and anaerobic composting. In the aerobic composting, the composting which is done in presence of the air, that we call it as an aerobic composting, and which is done in the absence of air, which is called as an anaerobic composting. Now we will be seeing the microbiology it is involved in this. Now here the proteins, amino acids, lipids, carbohydrates which are present in municipal solid waste, it is going to react with the oxygen and the nutrients which are present in the soil along with the microbes. It is going to have the compost along with it is going to liberate the CO2 and NO3, SO4 and your heat. Okay, so here what happens in your aerobic composting is the compost is going to be get ready with a very less amount of time as compared to the anaerobic composting, and it is also going to give the less smell to the surrounding areas as compared to the anaerobic composting. In the anaerobic composting, what is going to happen is we are going to do the anaerobic composting in the absence of air. So here it is going to release O2, methane. Okay, and the CO2 is going to be get released, whereas your aerobic composting, it is going to liberate the CO2, H2O and along with the nitrate and sulfate along with the heat. Okay, we will see the microbiology of anaerobic composting. Here the your hydrolysis, lipids, saccharides and polysaccharides, acid, nucleic acid, fatty acids, monosaccharides, amino acids, purines, it is going to act with each other, and it is going to form the substrate like the methanogenic substrate, the formate methanol amines, acetate, methane methane plus CO2 it is going to release. So this is how your anaerobic composting is going to give a bad smell, and as well as the anaerobic composting as compared to the aerobic composting, it is going to take the more time. Now we will see what are the factors which is going to be important in case of your composting. The factors or design consideration that is going to be important for the composting process. In this first one is the particle size. Whenever we are going to add some of the municipal solid waste, we should see that the particle are in between 25 to 75 mm. That is around 1 to 3 inches. It should be there whenever we are going to mix some of the municipal solid waste into the soil. And carbon to nitrogen ratio we need to maintain it in between 26 to 31. We need to maintain the carbon source of carbon is your straws, sawdust, paper, and to increase the nitrogen value we need to add the sludge and the slaughter wastewater. Then the blending and seeding. Okay, proper blending of carbonaceous and nitrogenaceous material for proper maintaining the C, and it is very essential. It is also involves the addition of volume of microbial culture sufficiently at a larger scale to affect the decomposition of the receiving material. So blending and seeding is also very important. Next is your moisture content. We will be keeping it as normally moisture content about 55%. If it is goes below the 40%, the rate of composting will be slowed down, and if it is too high, if it is reaching 70%, then what will happen is the anaerobic conditions would going to be get set. And mixing and turning. See, if you, in order to have the aerobic composting, the mixing and turning is very important, because the outside atmosphere also we needed to have some amount of oxygen in order for the survival of microbes. And if we don't have the turning and mixing of the municipal solid waste and as well as the soil, then the anaerobic conditions will prevail. The temperature what we are going to maintain for having the compost is around 50 to 55 degrees Celsius. Okay, and the temperature goes beyond 66 degrees Celsius, then the thermophilic temperature is going to be get set, or the more heat is going to be set, and the bacteria are going to get die. And then the air requirement, we need to have the 50% of the excess air we should transmit in order to have the aerobic composting. Okay, next we will be seeing regarding the pH control. Okay, pH we need to maintain in between 7 to 7.5. Okay, to minimize the pH, it is going to be above 8. Okay, initially the pH of the municipal solid waste will be around 5 to 7 in the first few days, and then it is going to drops below 5, and then at the end again it is going to in between 7 to 7.5. After 3 days the temperature reaches and thermophilic stage, and pH is going to rise in between the 8 to 8.5. Okay, in any stage the pH should not go below 4.5. It is going to create an acidic condition, then the acids is going to be developed, and it may affect the working of the microbes. Then the control of odor problem is normally it is there in your anaerobic compost. Then the pieces of magazines, books, plastics material cannot be decomposed in a short time because of the insufficient amount of O2 in case of whenever we are going to add the solid waste. In order to minimize the odor problem, it is important to reduce the particle size, remove the plastics and other non-biodegradable elements from the organic matter, as well as we needed to maintain the proper moisture, proper temperature, proper C/N ratio we need to maintain, or else it is going to create the problem. Then the important, we will see some of the types of your aerobic and anaerobic composting, that is Bangalore and the Indore method. Now the first method of your composting is the anaerobic composting. We are having the Bangalore method. This is nothing but your anaerobic compost. Here around 150 centimeter trench is going to be dug out, and then the layer of night soil, that is a 5 centimeter thick, we need to maintain. And then succeeding layers of solid waste and night soils has to be added in a pit, which is in a pit, and stack about 30 centimeter above the ground pit. Okay, and then at the end the soil cover has to be added. See here, you can see the diagram of your Indore and Bangalore method. Here normally the depth we are going to keep it as it is. Normally it is going to vary in between 1.5 to 3 meter. Then alternate layer of the soil and night soil and the soil has to be added. Then whenever we will be keeping it above, we should cover it the soil cover of around 25 to 30 centimeter, and the refuse the thickness should be around 15 to 25 centimeter, and the night soil should be around 5 centimeter thick. And if we keep it like this without disturbing it for the 4 to 6 6 months a good amount of manure we are going to get, as well as it is going to produce the methane here in case of your anaerobic decomposition or anaerobic composting. Your aerobic composting is, we call it as the indoor method. You can see that we have kept a space here. Also, we will be creating a pit. Inside these pits, so the mixture of the soil and the night soil will be added, and we will be keeping the 60 centimeter strip open, so that as it is the having the aerobic composting, what we need to have is we should have the turning of the municipal solid waste again after a few days. After 11th day, we will be turning it, and then so that the air can be entered inside. So this is what we will be doing in case of your indoor method. We will be turning, and then first turning, and then pit filled, then again the second turning will be done here. Okay, so if we keep like this, within 1 month we will be getting the manure for your indoor method of composting or aerobic method of composting. Next is mechanical method of composting. In the mechanical method of composting, we will be utilizing some of the equipments of composting. Mechanical method of composting, we will be utilizing some of the equipments such as your screening and all. In order to reduce the size of the waste material, we will be using these equipments. Along with that, we will be using some of the other things also. Here we will be for having the power for handling the material. Okay, for example, for here we will be using the trucks and all, and then again for mechanical separation of the particle, we will be using the metallic and non-metallic particle. We will be separating by using the different types of the separating system, as we have seen in the different in your last module. We have in the processing technique, we have used the element separation. For that metallic and non-metallic particle, we have separated it, and then for pre-treatment of the compost, for size reduction, screening and all, we have seen in the last particular class. Then the controlled decomposition, we need to maintain some of the temperature, we need to maintain the humidity. In all these cases, we need again the help of the electrical and mechanical instruments. So this is how your mechanical composting will be done here. So we have covered the module on composting. Later we will be covering the module on the landfilling. Now we will see what is a sanitary landfill. Sanitary landfill is nothing but the engineering design facility where we are going to dump the solid waste in a appropriately designed land, where after dumping of the waste, we will be having some of the practices like we will be using some liners and gas extraction, and then we will be preventing the environment, whatever the problems that we are going to have by the open dumping, the problems we are going to reduce by having the sanitary landfill. This is if you remember this diagram, I have already explained regarding this. The solid waste heaps, we are going to keep one above the other, and at the bottom we are going to have the liner. At the top again we are going to have the liner, and hence we are going to maintain the anaerobic condition, and whatever the gas is going to be get extracted, we will be getting it from the top, and the leachate we are going to get it from the bottom. So it is an engineering design facility. The methods of landfill are nothing but the area method, trench method and canyon method. Area method is used where the water table is at a shallower depth, where what we are going to do is, here we will be placing the solid waste into the surface or a pit, and along with having the barrier to it, and we are going to dump it wherever the area method is used, wherever the water table is at a shallower depth, and the trench method is used where the water is at a greater depth. Here we are going to excavate the pit as shown in this particular diagram. We are going to dump the solid waste heaps inside this particular pit, and then at the bottom we will be placing first liner, and then again top we are, in order to maintain the anaerobic condition, we will be we will be closing it, and we will be getting the methane gas out of it, and then it can be utilized as a source of energy. Then leachate is also going to be collected at the downside. Then canyon method, it is used to be in valleys, but here it is going to create the unhygienic condition for the people who are going to live in the valleys. Then the advantages and disadvantages is we have advantages is it is going to give the job opportunities for the unskilled person. We will be getting the methane which can be utilized as a source of energy, and again after the completion of that particular landfill, we can utilize it for the having the parks and all. Disadvantages, the wherever we are going to have this particular landfill, there the rates are going to be get reduced, and if it is not going to be managed properly, then it is going to create them hazardous condition to the people who are going to live in the surrounding areas, and also it is going to create groundwater contamination if we are don't maintain the sanitary landfilling correctly. Then site selection for landfill, the haul distance should be minimum, the location restriction, it should not be near to the cities and your waterlogged area and low lying areas, and the available land area should be more, so that the waste can be accommodated for the period of around 5 years. And then the site assess, the roads should be good amount of broader roads should be available. Then the climatic conditions, where it should not be too hot, and it should not be there in too rainy conditions, or in the places then surface hydrology, the groundwater table should be at a greater depth than local environmental conditions we need to consider. Then usage of completed soil can be as I have told, it can be used as a parks. So this is how we need to select the landfill sites. Now we will see how we can have the control on these whatever the gases that has been generated in the sanitary landfill. We can collect it by using the active and passive the gas collection pumps we can have, and the leachate can be collected by having your collection point over here. In detail, the collection of a leachate and the collection of the gases has been explained to you in the previous classes. So, if you want in detail regarding the sanitary landfill, your gas and your leachate collection, you can refer to my previous videos that has been already uploaded. So, this is how we have covered the module revision of module 4. Actually it is an overview, so if you want in detail, you can refer to my the previous videos, so you are going to get the things in detail in those particular videos. Thank you.